Question number 1. The kinetic energy of a projectile at its maximum height is 1/4 of its kinetic energy. What is the angle of the projection of the projectile with horizontal? Neglect the air resistance. We know that when considering a projectile motion, if the initial projectile angle is projected angle is theta and initial velocity is u, we know that horizontal velocity component is u cos theta. It is not changing at the motion. Therefore, at the maximum height, the horizontal velocity component is u cos theta. But at the maximum height, vertical velocity component is 0. Therefore, we can write maximum kinetic energy at the maximum height, half m u cos theta squared. Initial kinetic energy is half m u squared. We have to get resultant velocity. They have given that kinetic energy at the maximum height is 1/4 of initial one. Then we can multiply this one by 1/4. Then we have to find the angle theta. I will cancel out m and m, u squared, half and half. Then cos theta squared is half, cos 1/4, cos theta is half. Cos theta is half, then it means theta angle is 60 degrees. Then we can get answer is fifth one. Question number 2. Consider the following statements about a pair of action-reaction forces. We know that there are 4 main properties for action and reaction. First one, equal in magnitude. Second one, opposite in direction. Third one, acting on the same action line. Fourth one, acting on 2 bodies. First statement A, they are equal in magnitude but opposite in direction. Yes, it is correct. Statement A is correct. They are act only on objects touching each other. No, it is false. When considering action and reaction between Earth and Moon, we know that bodies are not touching, but we can consider gravitational forces on each objects are action and reaction. Therefore, statement B is false. It is not compulsory to touching each other. Then next one, part C. They act on the same object. Now we know that action and reaction is acting on 2 bodies. Therefore, only A is true. Answer is 1. Then question number 3. As shown in the figure, a bullet hits a wooden block placed on a smooth horizontal surface and M's within the block. Consider the following statements. There are 3 statements. We have to consider the correctness. A, the law of conservation of linear momentum is valid for the collision. Yes, it is correct. We know that when considering 2 objects, when colliding each other, there are equal and opposite forces on 2 bodies. Therefore, when considering the system, there is no an external unbalanced force. It is the requirement to use the conservation of linear momentum. Therefore, we can use conservation of linear momentum for the collision. Then part B, the law of conservation of energy is valid for the collision. Yes, it also correct. But when considering mechanical energy, it will not conserved because of there is a kinetic energy loss. But that kinetic energy loss is converted into another energy type. Therefore, conservation of energy is valid, but mechanical energy is not conserved. Then B statement also correct. C statement, a part of kinetic energy of the system is lost due to the collision. Yes, it is correct that kinetic energy loss is converted into heat energy, sound energy or any other energy form. Then A, B, C all are true. Answer is 5 for the question number 3. Then question number 4. The graph of the variation of the velocity v with time t of an object is shown in the figure. The corresponding displacement time graph is best represented by. We can consider given velocity time graph. We know that velocity is representing gradient of the displacement time graph. For the first part, velocity increases, therefore gradient of the displacement time graph increases. Gradient means this acute angle. It is increasing. Then for the second part, there is a constant velocity. It means gradient is not changing. There is a constant angle for that part. Then for the third situation, there is a decreasement of velocity. Therefore, gradient should be decreased and velocity at this point is 0. Therefore, graph should be parallel to the x-axis for the final position. Then gradient, then velocity increases in minus direction. Then we can get direction of the motion should be opposite. It means displacement is decreasing like this, but angle is increasing. This one is the correct displacement time graph. Then we can obtain third one is the correct answer for question number 4. Question number 5. A circular disk of moment of inertia about a perpendicular axis to its center is 8. It is smoothly pivot from the center and initially rotates at constant angular speed of 40 radians per second. When a constant torque is applied for 10 seconds, the angular velocity of the disk reduces 20 radians per second. What is the magnitude of the applied torque? We can use tau equals I alpha equation. We have to find the torque, moment of inertia at 8. We can write alpha. Alpha is the angular acceleration. We can write it rate of change of angular velocity. Omega 2 minus omega 1 divided by t. Change of angular velocity divided by time. Then we can substitute it. Omega 2 value is final angular velocity 20. Omega 1 is initial angular velocity 40 divided by 10. Then we can get 8 multiplied by minus 20 divided by 10. The answer is minus 16 Newton meters. Minus means it is an opposite torque because of there is an angular deceleration. Then answer for the question number 5 is second one. Question number 6. From a homogeneous uniform circular plate of radius 2r, a circular part of radius r is removed as shown in the figure. The center of gravity of the remaining part of the plate is most likely to be found at. We know that if there is a circular disc, center of gravity should be midpoint. It means center of the circle. But this part has been removed. Therefore, center of gravity should be moved in right hand direction. Therefore, we can obtain D as the center of gravity of the given object. Then answer is 4. Question number 7. The coefficient of static friction between a small coin and surface of a horizontal turntable is 0.36. The rotational speed of the turntable is 30 rpm. What is the maximum distance from the center of the turntable at which coin will not slide? Take phi value as t. If this one is the turntable, and this one is the coin. We can mark forces on coin. Weight, reaction, frictional force. When rotating it, we can use F equals ma towards the center. Force towards the center is the friction. We can substitute it mu r. M. We can use acceleration, centripetal acceleration v omega, omega squared rho, v squared over. I will use omega squared r because of we have to find the angular velocity, omega squared r. And we know that r value is, reaction is equal to the weight of the object. Therefore, we can substitute r as mg, m omega squared r. Then we can cancel out m and m. Mu value 0.36, g10. We have to find omega because of they have given angular speed, rotational speed, rpm. We know that rpm value is rpm divided by 60 is rps, revolutions per second. It is equal to the frequency. Frequency 1 over period. Period is 2 over omega. Then we can use this two relationship to find the omega. rpm value 30 divided by 60. Omega divided by 2. Phi value is given as 3. Then we can cancel out with 6. Answer is 3. 3 squared 9 r. 9 divided by 9 1 0.04. 0.36 divided by 9 0.04. 0.04 into 10 0.4 meters. It means 40 centimeters. Then we can get fourth one is the correct answer. Question number 8. Two boxes A and B of mass 10 kg and 5 kg respectively and made of different materials are placed on a rough horizontal surface as shown in the figure. The coefficient of kinetic friction between box A and the surface is 0.5. When a horizontal force of 100 Newton is applied to a box A, the reaction force between box A and B is 40 Newton. What would be the coefficient of kinetic friction between box B and horizontal surface? First of all, I will mark forces on two objects. 100 Newton is an applied force. There is a reaction 40 Newton. Reaction on this object also 40 Newton. There is a friction on this one. Frictional coefficient between A and surface is 0.5. Therefore, this friction is 0.5 times reaction. Reaction is equal to the weight of the object. Weight of the object is 100 newtons because of it is 10 kilograms. Then reaction also 100 newtons. Then we can substitute F equals mu r, mu 0.5, reaction 100. Then 50 Newton reaction, 50 Newton frictional force. There is a frictional force on this object. I will consider it as mu r. Mu, mass of the object is 5 kilograms. Therefore, weight 50 Newton, reaction also 50 Newton. Then reaction is 50, mu times 50. Then we can use F equals ma to the object A. F equals ma in horizontal direction. Supporting force for the motion is 100. Opposite forces are 40 and 50. We have to subtract 90. Sum of opposite forces. Mass 10 kilogram. We can find acceleration is 1 meters per square second. Then I will consider this object. When considering this object, there is the same acceleration both because of objects are contact each other. Force, supporting force 40, opposite force mu into 50. This frictional force. Mass 5 kilograms. We have to find. We have to consider acceleration is 1 because of there is a common acceleration for both objects. Then we can find mu value. 40 minus 5, 35 divided by 50 is the mu value. Divide by 510, divide by 57. 0.7 is the frictional coefficient between surface and object B. Then we can substitute it. Then we can get the answer is first one for the question number 8. Then question number 9. A small solid sphere made of material having density beta is released from rest at a depth h below the surface of the water in a tank. The density of water is rho is greater than beta. What is the maximum height of that sphere? Will rise from the surface of the water, neglect all viscous forces and surface tension of water. Now they have given that density of object is less than density of water. Therefore, the upthrust on the sphere is greater than weight. Therefore, there is an acceleration in upward direction. Viscous force and surface tension negligible. Therefore, we can consider that these two forces are constant for the whole motion from this release level to fluid level. Then we can use a constant acceleration. I will find the acceleration by using F equals ma. Upward force upthrust, downward force mg weight equals ma. We can substitute upthrust v rho g. mg v density of the object beta g. Volume into density of the object is mass. Again v beta a. We can cancel out v from all terms. Then we can get acceleration is g is a common factor, rho minus beta divided by a. Then I will consider a to b motion, and we know that this height is capital H. Therefore, we can use v squared equals u squared plus 2as for the a to b motion. V squared is final velocity at this point. I will consider it as v. V squared u0, initial velocity is 0. 2 acceleration is this value, g times rho minus beta divided by a. Then we can use an equation from B to C motion. B to C means motion under the gravity. Velocity at this place is 0. Then I will use same equation B to C. V squared equals u squared plus 2as. V squared is square of final velocity 0. Square of initial velocity for the BC motion squared this point is this value 2g rho minus beta divided by a. It is square of velocity, therefore I will substitute directly. Plus 2 into acceleration minus g. I will consider this height as simple h. We have to find the simple h value. Then we can get minus 2gh term to the left hand side. 2gh, 2g rho minus beta divided by beta. Then we can 2g this value 2 into acceleration into displacement is s. It is h. We have to substitute h. Then there is a h term in this expression. Then we can cancel out 2g and 2g. Then we can subject h rho divided by beta minus beta divided by beta 1 into h. Then answer for the question number 9 is fifth one. Question number 10. A water tank having a large cross-sectional area is kept on a support of height h from a small hole close to the bottom of the tank. Eject a horizontal stream of water. Water strikes the ground at a horizontal distance d from edge of the tank as shown in the figure. What is the height y of water in the tank? we can get velocity of water as root GH. If the site is given as y, therefore root GY. Root 2GY, because we have to use Bernoulli's principle between this point and this point, and we can obtain this equation. You can remember this one. If there is a large cross-sectional area, it means we can consider velocity of the surface as 0. Then velocity, ejected velocity of water or any other fluid is root GY. Then we can use horizontally A to B, S equals UT. It is a projectile motion, therefore we can use S equals UT for the horizontal motion. They have given this distance as D, then D equals velocity 2GY root time T. Then we can subject time D divided by root 2GY. D divided by root 2GY. Then if this site is given as simple h, then we can use initial vertical velocity is 0. Then we can use vertically S equals UT plus half AT squared. Initial displacement is h. Initial downward velocity 0. Therefore, U term 0, UT term also 0. Half into acceleration is under the gravity g. T squared is the square of this one. D squared divided by 2GY. Then we can cancel out G and G. We have to subject Y. Then we can get Y is D squared divided by 4H. Then answer is third one for the question number 10. Question number 11. As shown in the figure, a metallic ball of mass M is connected by two massless wires, each of length 2 meters, to a vertical rod. The wires are taut and rigidly fastened to the rod with a separation of 2 meters. The setup is rotating at a constant angular velocity about axis of the rod. The tension of the upper wire is twice that of lower wire. What is the angular velocity of the ball? I will mark forces on ball. Tension of upper wire 2T, they have marked it. Tension of lower wire T. Angle, this angle and this angle 30 degrees. Weight mg. Then we can use F equals ma towards the center. 2T cos 30, horizontal component of upper wire, plus T cos 30, horizontal component of lower wire. These two forces are horizontal forces towards the center. Equals m omega squared r. We have to find the angular velocity, omega value. 2t cos theta 30 plus t cos 30, 3t cos 30 equals m omega squared r. It is the first equation. Then I will consider vertical equilibrium. Upward force on the sphere is 2t sin 30. Equals to downward force T sin 30 plus mg. Then I will subtract this term from the left hand side. T sin 30 equals to mg. Second equation. Now we can divide second equation and first equation. T is cancelling. Sin 30 divided by cos 30 tan 30 divided by 3 equals m is cancelling. G divided by omega squared r. Tan 30 is 1 over root 3 into 3 g omega squared. We have to find omega. Radius is given as root 3. Then we can substitute r value root 3. We can cancel out root 3 and root 3. Then we can subject omega. Omega squared is 3g, omega is root 3g. Root 3g means we can get third one is the correct answer. Then question number 12. The upper half of an inclined plane of inclination theta to the horizontal is smooth while the lower half is rough. A block starting from rest at the top of the plane slides down and comes to rest again at the bottom. The coefficient of kinetic friction mu between the block and lower half of the plane is given by. Then we can get length of, I will consider length of plane is 2L, then upper half L and lower half L. Finally, potential energy at this place should be converted to work done against the friction because of there is no kinetic energy at the end of the motion. Then potential energy mgh should be equals to work done against the friction is frictional force into displacement, distance. mg, this angle is theta, therefore we can substitute h value as 2L sin theta. Frictional force is mu r. X is distance corresponding to the friction. Friction is acting on this part, therefore distance is L. We can cancel out L and L. mg into 2 sin theta equals mu. We know that when moving the object, weight is like this, therefore weight component perpendicular to the surface is mg cos theta. We know that this angle is theta. Then reaction is equal to the weight component perpendicular to the plane. Then we can use it mg cos theta. mg is cancelling. 2 sin theta divided by cos theta is mu, frictional coefficient. 2 sin theta divided by cos theta is tan theta. It is mu. Then we can obtain correct answer is first one. Question number 13. Two identical triangular isosceles wedges, each of mass m are placed next to each other on the rough horizontal surface. A solid cylinder of mass m is placed on the wedges as shown in the figure. Assume there is no friction between cylinder and wedges. The coefficient of static friction between the wedges and the horizontal surface is mu. What is the largest value of m, capital M, that can be balanced without slipping wedges? I will consider forces on cylinder. There is a reaction. This angle is 45 degrees. Same thing, reaction, this angle 45 degrees. Weight of the object, capital Mg. Then we can consider vertical equilibrium of this cylinder. Upward force R sin 45 should be equals to Mg. We can get R value is Mg divided by sin 45. Then I will consider forces on a wedge. Weight Mg, simple Mg. I will consider reaction R dash, and there is a force R in this direction. This angle also 45 degrees. Then when considering equilibrium, vertical equilibrium of wedge, we can get upward force R dash equals downward force simple Mg plus R sin 45. Simple Mg plus, we can substitute R value as this one. Mg divided by sin 45 multiply by sin 45. We can cancel out sin 45. R dash is this one. Then I will consider horizontal equilibrium of wedge. Force in this direction. Now I will consider force in this direction. This wedge is trying to move in left hand direction, therefore friction is opposite this direction. It should be equals to horizontal component of this R. It means R cos 45. We can substitute depth value mu R equals R cos 45. Mu R dash. R dash means reaction on wedge. Then mu R dash is this one. Simple mg plus capital Mg. R value is this one. We can substitute capital Mg divided by sin 45 times cos 45. We know that sin 45 equals cos 45. We can cancel out it. Then we can subject capital M value. Mu mg plus when considering this cylinder, there are two upward forces. 2r sin 45 should be equals to mg. Then r should be 2 sin 45. Same thing. R dash is equal to mg plus r sin 45. In this one, there is a term 2. Now, again, we have to use 2. Mg divided by 2 sin 45. Mu mg plus mu capital Mg equals to mg divided by 2. I will multiply all terms by 2. Before it, I will cancel out g. 2 mu m plus mu m equals m over 2. No. We have to multiply it by 2. Again, when getting r dash, there is a term 2 in this one. Then multiply by 2. Then we can get all capital M terms to the left hand side. 2 mu m equals m minus mu m. Then m is the common factor. 1 minus mu. 2 mu m. Then capital M is 2 mu m divided by 1 minus mu. We can obtain fifth one is the correct answer for question number 13.